All right, so chapter 5, day 2, we're going to be dealing with Venn diagrams, which we kind of started to talk about on Friday. Two-way tables, which is something we've actually already talked about, and intersection. All right, so I'm going to fly through a couple concepts really quick, just making sure we're all on board, which I just talked about most of these anyway. So don't write down any of these. Law of large numbers we just talked about with every single one of 2 through 8. What is the sample space? What is the sample space?
Set of all the possible outcomes.
Set of all the possible outcomes. I start denoting it by writing what? And then I start here with what? Brackets, and I start listing them out. What is an event as opposed to a sample space? You can be general here. A particular outcome. It's just part of this. So it could be only one, like rolling a 1, or it could be a group of them, like rolling an even number. What is complement? Everything we don't want, the opposite. So if I want to write the complement of A, how do I write that? Like write it like this. And then you said 1 minus probability of A. We talked about mutually exclusive means they what? They do not overlap, which means not mutually exclusive means they do overlap. What do I know about the sum of all probabilities?
1.
So if I'm writing this, what was I trying to write here if I had something before and something behind? So that just kind of flies through a really quick refresh of most of the things we went through on Friday. So this I want you to write down as basically a more specific way you can write your homework answer. For those of you who were like, I get it, I know what it means, I don't know how to write it. So it's the fact that we do it a whole bunch of times. So after many, many trials of some specific actual trial, and I've done it with another word before or left out. I know that I have trial. I've done it before and not written the word trial there, and people got confused with it. So yes, it sounds repetitive, but when you actually plug something in, it should make more sense. Are we definite that exactly that much is going to happen? So we predict, and we're predicting that it's going to be close to there, so it's going to be about. And then you plug in your probability number. And we're predicting about that much will actually result in whatever it is that we're trying to get. And that word success doesn't always mean success in the way you think about it in other classes. Like, it doesn't always mean like something good happens. It's the event in question, I guess. So if I went back to our homework, this is probably about drug testing now. So filling this one in, I would say after many, many trials of what?
Drug tests.
drug tests, and I think that's all it's athlete drug test for performance enhancing. We predict about 0.03 will result in a false negative. So that's what you're doing here. It could be something like, we dealt with it. This is actually one I don't think it's going to work anymore. We did the chart on Friday about all three children. Oh no, all three coins landing on tails was probably 1 out of 8. So if we went with that, it'd be after many, many trials of what? So this was the one for Friday. It said we flipped 3 coins. We want to find the probability that all of them are tails. Probably all of them are tails is 1/8. So this would be after many, many trials of what? Of flipping 3 coins. So this might be more than one thing happening. So this is many, many trials of flipping a coin 3 times. We predict that about what? 1/8 will result in all 3 being tails. It just kind of helps with some people who are like, I get it, but I don't have a way I want to write it. Venn diagram. I don't know if I want to write this in here. I probably wouldn't waste time to write down the definition of Venn diagram because I feel sure that you know what that is. A diagram used as a pictorial representative for a probability concept or rule. I don't feel like you benefit any from knowing that definition. Either know what a Venn diagram is or you don't. Alright, so we're going to go through 3 examples. We're going to do a couple different things with all 3 examples. So, example 1, rolling a 2 on a die. Write that down. Example 1 is rolling a 2 on a die. What would a Venn diagram look like for this? Alright, let's skip ahead. So say room there. Example 2. There are 32. Actually, we're going to write them all down and we'll get back. Example 2. There are 32 students in the class. 8 of them are juniors and 20 of them are seniors. Write that down. We have a 3rd example, but let's go ahead and do these 2 first. So, how many events do I have in this example? How many events do I have in this example?
3.
Well, maybe 3. How many variables do I have in this example? Variable is generic.
1.
What do you mean generic?
What's my generic category here? A little bit more specific than that. What's my generic category that I'm split it into?
Junior.
Which is grade level. So that's grade level is my variable here. So with this one, what's it going to look like? We did one of these on Friday. I might have done this example on Friday.
I mean, it'll be 1 to 6, but I don't know how to make that.
Alright, what does this Venn diagram look like?
And then when we put the 32 in the middle and that remaining 4.
So what Venn diagrams are, before my class you would think of that as a Venn diagram. and we get a little bit more specific. So what does this Venn diagram look like?
Is it gonna have 3 circles?
A rectangle with circles.
A rectangle with how many circles? 2. What do those circles do or do not do? They do not overlap. So I'm going to go ahead and make a key and write, so I don't have to write as much. Let J be juniors. And let S be seniors. So what does the box represent? My sample space.
So all 32 students.
So all 32 students, and I'm going to have 2 separate circles that do not overlap because these 2 events, what? Are not mutually exclusive, or are mutually exclusive. So J, S, how many of the students are juniors? How many of the students are seniors? Am I done? Because I only have 28 so far, but there are 32 of them, so where did the last 4 go? Just anywhere in the box, but not in the circles. So they are included in this sample space, but they are not a junior and they are not a senior. So each of the circles represents an event. The box represents sample space. So now that we've done this, what does this look like? A rectangle with 1 circle. So it either is or it isn't.
So we don't make a circle for every option, we just make a circle for the option one.
Yeah. So this one might get a little confusing for your notes. I might choose to do this one, and usually I would do it as the number. But then I'm going to have 2 numbers in there and it's going to look confusing. So how many are in the circle? How many are outside the circle? We wrote it with how many there are. Could I do the same thing with probabilities? If I did this with probabilities, this would be what? 1 out of 6, this would be? Does that change anything? I don't care how you write it. I usually do this just because there's not as much to shove in there. Alright, and then our third example, go ahead and write that. So what's different about the way this is going to look? It overlaps. So asking the questions that I was asking earlier, how many events do we have mentioned? Kind of 3. How many variables do we have here? 2. What's one of our variables? Grade level. What's the other one? Gender.
What are the events again?
Really the events here technically are just juniors and boys for right now.
No, but yeah, but what is it?
Things that we want, categories of things we want, kind of.
So how do we have 3?
This 2. So I'm going to do, let J be juniors. Let B be boys. But I mean, people thinking 3, it's fine that way. So our circles are going to do what? Overlap. It doesn't matter which one's left side, which one's right side. Alright, so we have to read this one in pieces. So 8 of them are juniors. Where would the 8 go? In the left circle. Don't write that. Where would the 2 go? in the middle where they overlap, where would the 14 go? What?
Specifically not the middle.
Right, so these are different because this 8 is for the very specific. The 8 is where on this? The entirety of this J circle. So don't draw what I'm drawing, but this is 8 as opposed to what is 14?
Just the part of the circle. That's what it says.
So you have to pay attention to wording with stuff like that. So my 8 that goes here, but I have 2 here. So do I also put 8 here? So this whole circle is 8, but I've already accounted for 2, so how much is left?
6.
And then here, it went ahead and dealt with how much of the circle was just out here, and it specifically told you that was 14. Am I done?
No, let me put 10 in the box.
Because that gives me 20, 22. There's 32 of them, so 10 of them are left outside the box. I'm going to come back to that. What did union mean? Or, well, it looks like a U. I'm not going to do one with example 1, but this is continuation of the same example. So with example 2, we said those events were what? Mutually exclusive. Which means, what is my equation for or if events are mutually exclusive? So this is showing your work how I want it. If I give you this, you would need to show me that I can use just J because I've already done I already wrote on the other page that J is junior. Plus probability of senior. So I have to show that part, and then I write my numbers for each. So what is my probability of junior? Not just 8. 8 out of 32. Plus what's my probability of senior? And then I actually add that together and get, which reduces to, if this is a quiz, this counts, and this counts. Sorry, video people. This counts as part, this counts as part, this counts as part. So what's different about junior and boys? These are not mutually exclusive, which means now I'm going to have probability of junior plus probability of boy, what? Minus probability of J and B. So I've got to think about this if I have a Venn diagram. What is my probability that it's a junior? How many total are in the junior circle? 8. So this one gives me 8 out of 32. Plus how many total are boys? 16. Minus how many are both? 2. And that gives me what? Which reduces to
11 and 16.
Alright, so for now, the only thing I want to write about these is union means or. So probability of A or B is the same thing as writing probability of A union B. So what do you think intersection is going to mean? And. So probability of A and B can also be written as this, but upside down. So if you're ever writing out a problem, I don't care if you write and in words or write this symbol instead. Same thing with union. But if I give you this or this, you have to know what it is to be able to go from there. All right, so now we're going to talk about a two-way table. You don't need to write like definition of two-way table or anything. What is a two-way table? We've used two-way tables for like weeks in the beginning. What is a two-way table? That is the part that most people overlook. It is two variables because you've got a variable going this way and a variable going this way. So if I tried to say, write a two-way table for example 1, it's not going to be a two-way table. What about for example 2? Because why? It's only one variable. So let's write a two-way table for this example. What is one of our variables? Grade level. It doesn't matter which one goes on the top and which one goes on the side, ever. As long as all yours on the top are together. All yours on the side are together. So let's say we're going to do grade level up here. What are my options for grade level?
Juniors and seniors.
What are my options for, what's my other variable? What's my options? So, looking at this one quite literally, let's think through this one first. We know that how many, stop writing and watch me for a second because I don't want you to draw and measure yourself out. If I do this, how many go here? How many seniors are there? How many juniors are there? How many seniors are there? Just say that. Oh. Let me fill this out then. So, okay, how many boy juniors are there? How many boys are not a junior? Oh, this is fun. I'm gonna get a different problem. Okay, yeah, y'all can fill this one out. I wrote a different problem. I changed it. Oh, I know which one I'm looking at. Alright, so we can really look at this as, like, obviously in this category it's girls. But if it's anything else, this is the what to that. So it's not wrong to write it as the complement of that, even though in this scenario I'll probably just go ahead and write girls. So now you've got to fill in pieces here. So what goes here? So how many total boys? So you're just filling in pieces. Well, if 16 are boys, how many are not boys? So if we have 16 not boys, and 6 of them are juniors, how many of them are seniors? and we had 8 juniors. We have 32 total, so how many of them are seniors? I should have used different wording. I did not mean to use the same problem. I wasn't trying to use the same problem from example 2 to example 3. What does this look really similar to? This is the exact same thing as if we had done the two-way table is the exact same as our Venn diagram when we do this. It just looks different. So can I get the exact same information out of it? Yep. So some of the problems you're going to be working on are going to say either make a Venn diagram or a two-way table. It shouldn't matter which one you use. So now that we've thought through this one as a two-way table, I don't need you to draw this one, but since it's only one variable, we would only have grade level, we wouldn't have anything over here. This is one that I was thinking about. So how many juniors are there? How many seniors? How many total are there? Which means there's also something that is neither, which would be, but that's not a two-way table because it's just one variable. So you can only technically do a two-way table for anything that is a two-variable concept. Now, this example here, what is the probability that someone is a boy and a junior? 2 out of 32. Did you have to do any math to do that? You just saw where they did what? Overlap. Same question here. What is the probability that it is a boy and a junior? 2 out of 32. You didn't have to do any math, you just saw where they overlap. As of right now, that's all I want to talk about with and. Now there's math behind and, but we don't have to get there yet. It's too confusing to put it all together at once. So with example 2, what is the probability that someone was a junior and a senior? What is the probability that someone was a junior and a boy? I want you to write these down. What did you initially tell me about the two events, junior and senior? So if they are mutually exclusive, what does this symbol mean? If they are mutually exclusive, the and is going to be 0 because literally they do not overlap. There's nothing in the overlap. Whereas here, they're not mutually exclusive. There is something in the overlap, which means they're not mutually exclusive. So if the and is 0, they're mutually exclusive. If the and is not 0, they're not mutually exclusive.